Hey everyone, welcome back to the channel. My name is Darsh Joshi and I'm a BTech Computer Science and Engineering graduate, and I'm currently working as a developer in a tech company. Let's get started with oops concepts and oops, I did it again. That's a good joke. I make it often. I'll make it often, and yeah, it's funny to me. Maybe not funny to you, but anyways. Here's a little presentation that I made. Let's start with second. Okay, perfect. So why oops matters? I mean, why does object-oriented programming has to matter? So when we first start writing code, we usually write small programs with a few functions and some variables, which works perfectly fine. And that's not the case with something which can be used as a production level software or a production level code, basically, in short. So for that to be a good thing, the code to be a good thing, it should be scalable. It should be able to handle and manage a lot of users. So here's something I've made. I think I should clear this up and I should start it all over again. So what is object oriented programming? You should ask this question to yourself because it's really a great question. So I did it again. This is an object oriented this programming. So what is an object? An object is anything. It could be anything. In Python it is everything almost. Like if you are using a list, that's an object. If you're using, let's say, a dictionary, that's an object. If you're using a set, that's an object in some or the other way. So object oriented programming basically is structuring your code such that my camera is off, I guess. Okay, now you can see me. So object oriented programming is basically sculpting your code such that it has a definite structure. Every object has a definite structure and you can make your own objects. So the template through which you create an object is called a class. A class would contain some properties. Class is basically a blueprint and it would have some properties which would be applicable to all the objects which come under the class. So you can form an object from the class. It's like an instance of the class and it would contain all the same properties as the class. All good, I guess. So yeah, that's what oops basically is. I've given a brief overview of what will be doing in oops. Move the next thing. Next thing should be thing is the problem without oop, or we can say oops. That sounds better. So spaghetti code. Spaghetti code means long lines of code with no real meaning. Like, let's say you have a function. Let's say you are using a function and it has some really long lines of code and it returns a really small stuff like empty brackets or something. Then it's not really a good deal. I mean, you're writing too much and getting nothing in return. Something like that. I mean, long lines of code with no real meaning. That's what spaghetti code basically means. Repeated logics is, I mean, self-explanatory. I don't think I need to explain what repeated logic basically means. Repeated logic would that code has a lot of repetitions. Camera is lagging a lot, so I'll turn so that it's not really distracting anyone. not me and not you as well. So that's the thing with repeated logic. Without OOP, the code becomes a little bit harder to debug. I mean, if you are not using a specific structure, then it would be a bit harder to exactly locate where the issue is. That's debugging point. It is not so scalable. So we don't have any structure, then we cannot expand the structure. That's quite logical, I mean. And it's difficult to manage teamwork between this kind of things. So yeah, that's the problems which we face without OOP. I'll just say it object-oriented programming because OOP doesn't sound so good. I mean, so that's some of the issues. Spaghetti code also means that code gets a lot tangled and we don't really follow up with that. Just like spaghetti we see here, something like this. But anyways, let's move to the next slide. So the next slide is what is object-oriented programming. I've explained that in the first slide itself. I don't think it's that complicated so that I need to explain, but I'll do it anyways. So an object comes with two things, which is data and behavior. The behavior basically comes from the class in which the object is created. Oh, here, I'll clear all this up. Okay. So an object, let's say object would have two things, which is data plus behavior. Data would be unique for all class, not class, but like all objects, it would be unique. Possibly, I mean, depends from code to code, but I would prefer for it to be unique if I'm writing the code. But data basically refers to properties. Let's take an example of a student report card or just a student profile, let's say. So here's your student profile, and the student profile would contain a few details like name, age, mobile number, let's say, address maybe, and some other details. Let's keep. So this is all the data which can put there if we are creating an object out of this class. So in this case, student profile is a class, and name, let's say something. Names are basically names. Student's name in this case, first name plus last name. Age would be a number. This would be a string. Mobile number would also be a number. Address would be a string again. So that's basically a class here in this case. We'll be looking at all these in one of the future videos where we cover all this in depth. This is more of a brief overview of what object-oriented programming is. If I create an object out of this, so these are my properties: name, age, mobile number, and address. So name, mobile number, and these are my properties here. But if I want to, what behavior means? Behavior basically means what we can do with these properties. Basically, we can summarize all that as actions. Behavior basically depends upon methods. Methods are basically what we can, it's like functions which we can perform inside a class. Yeah, that's pretty complicated and pretty simple at the same time. Okay, Schrodinger's object-oriented programming. Cool joke. Anyways, So let's take another example of this. Say a class which is called car. I'm doing all this in Python, by the way. Class car, and this is like more of a sample code than a Python code, so deal with it. We are not going with programming right away. First we learn the theory, then we apply that in action. The car would have some specific properties like let's say color, have speed. Let's keep it max speed. Max speed is a thing. Acceleration would be a property. Braking be a property. Honking would be a property as well. So these are the properties, and let's say I'm making car. Let's call it something like code van, because goes with the channel pretty well. T code van would have the color gray. Why? I don't know. Came to my mind. Max speed, let's say 3 into 10 to the power 9 is the speed of light, by the way. Acceleration would be, isn't it? We are taking some assumptionary examples, so why not? Braking would be 0. I mean, it would take 0 time to brake. Honking would be negative 0, because we shouldn't really go with noise pollution. Jokes apart, like this would be instance of this class, means this is an object. So yeah, that's how objects basically work and function. So yeah, moving on, we have 4 pillars based upon object-oriented programming, which is encapsulation, abstraction, inheritance, and polymorphism, which is something which we cover in next slide, which is this slide. So let's learn about what encapsulation means. Encapsulation means the bundling data and methods together and restricting direct access to the internal details. You can think of it like a capsule. Everything is packed inside and we access what we need. That. Take another example. Let's take an example for this. We have not taken the first example. We cannot take the another example. Grammar. Anyways, encapsulation, I'll just write it over so that you encapsulate. Encapsulation is, let's take an example of banking system. For banking system, this is a good example for encapsulation. In a banking system, what we let the user do is do 2 things, which is withdraw and we let the user deposit money. The 2 things we let the user do. Let user do, but there's a lot of things don't let the user exactly do, like changing balance. Don't let the user do that. Don't let the user access to some other person's bank details. So no, let's keep it this way. So yeah, so basically this is what the user can do, this is what the user can't do. This is basically encapsulation. Put this all in a capsule and we let the user see what we want them to see and use. Perfect. Let's move on to the next slide. Right, should abstraction. So abstraction means hiding the complexity and exposing only and only what is necessary for the user. Let's take an example. When you drive a car, you use the steering wheel and the pedals. You don't need to really understand how the combustion engine works or how the behind the scenes are working, whatever the system is. Similarly, in object-oriented programming, the users of the class don't really need to see the complex internal things which you are doing. They only need to work with what's good for them. I mean, what they need to know is what they know. That's something my professor used to say when we are learning. I did it again. So yeah, this basically makes the system easier to use and reduces the cognitive overload for the developers. What's cognitive overload, you may ask, using such difficult words today for some reason, not sure. So what cognitive overload is, basically it is difficulty in understanding what the code is doing exactly. Over that we use abstraction. Good to go to the next slide. Next slide is inheritance. Inheritance basically means that we allow one class to reuse the properties and behavior of another class. Like let's take example of vehicles again. So let's say we have a class called vehicle class, and inside these would be some other subclasses. Call it class of cars, maybe class bikes, class truck. So they would have some common properties, but they would have some different properties as well. So we cannot confine them inside a singular class. So we make subclasses of things and arrange it that way so that it's easier to read and access. So I guess it's pretty clear. I mean, I don't think we need to go deeper in this. We're learning this, and so yeah, that's what we call inheritance. Written the example here as well, like vehicle, then comes the car, then comes the electric car. These are subclasses, they are inherited. Also this would be called the parent element. This is the child element, the child element of the child element, grandchild element. Doesn't work that way, but calling it humor, why not? The next pillar is polymorphism. Polymorphism basically means to have many forms, if we go with basic English. So what it means in programming perspective, it basically allows different objects to respond differently to the same method call. So let's take the example again. Clear this up. Then so let's say we have class animals, and inside that we have some method, let's call it make sound, and then we declare some other classes, like let's say dog. Then the dog would make sound as woof. We should ask iShowSpeed about that. Does it way better than I did. Let's call it bark. Woof. Doesn't look good. Bark. Grass. Cat. Would meow at this. Something like this. So these are basically properties of this class. They come from here. That's a good example of how we can understand polymorphism. That was the last pillar for object-oriented programming. Next thing which we'll be seeing is why object-oriented programming is important in real life. So object-oriented programming is not just theoretical, it's heavily used in the real world as well. By real world, I mean production-ready codes, basically. We don't program stuff in real life. So major programming languages like Java, as I've mentioned here, you can read these. They are built around the object-oriented programming principle. And large companies like Google, Microsoft and Meta basically build massive scalable systems as we all use nowadays. For example, you can see on your screen I'm using Google Slides, and I've also opened YouTube here because you guys don't subscribe before without telling. Anyways, so we have this course out. You can watch it and learn Python if you are not understanding any of these. Yeah, where were we? Yeah, we talked about companies, right? Apart from companies, many software like Android apps and backend systems and game engines, they all basically depend upon object-oriented principles. So yeah, that's a good reason why all this is important for learning, knowing. Next up, we have the benefits of object-oriented programming. It basically allows code reusability. We have discussed this. Code reusability, we have discussed that. Modularity, making the code really structural. That's what modularity means. Is that now? Easy maintenance, because the structures are clearly defined, then it makes it easier to maintain. Scalability, which means a lot of users can use it at the same time. I mean, it's scalable that way. Scalability is a good factor on why we should use object-oriented programming. And better collaboration. Better collaborations basically mean that you can just give the code to some other programmer. They would understand what's exactly going on by looking at the structure which we have sculpted. Okay, next slide is object-oriented versus procedural programming. So what's procedural programming? What we do by default, that's the procedural programming. Object-oriented programming, we have discussed it so far. So what are the factors which differentiate between these two types of program design basically? So procedural programming is a lot based on the functions which we make. It can be complicated, it can be simple, but it all goes to the functions. Object-oriented programming basically depend upon the object, has some properties and some methods which we can use. Procedural programming is hard to scale. It is scalable, I'm not denying that, but it's like difficult to scale it for smoother functioning. Meanwhile, object-oriented programming is really easy to scale and use because you have a structure. Structure makes things easier. This is not so secure if we take a look at production level softwares, apps or websites or whatever you are making. In this case, this is more secure because we have encapsulation. We can make private variables and stuff, private methods and stuff. Yeah, it's more secure than procedural programming. Also in procedural programming, a big issue is code duplication, and that's not the case object-oriented programming. Basically you reuse the code, which is the exact opposite of duplicating the code. Yeah, next up slide is real world example of a banking system. Instead of using the balance variable everywhere, what you do is create a class, define some methods, and work with it. Methods are basically functions inside a class. If we make some functions and we can work with it pretty easily, I mean, not as complicated as using the for loops and while loops and stuff. So yeah, moving to the next slide, why everyone must learn object-oriented programming. So that's the point of the video. I mean, we have discussed it so far. You know its advantages, you know its higher ground than procedural programming. On the other note, for students, object-oriented programming is really important because it's a commonly asked technical question in interviews if you are appearing for interviews. It basically forms a foundation for design patterns, and it's an essential part of backend development and production level applications. If you really want to become a software developer like myself, or you want to understand object-oriented programming, it's not optional, it's like fundamental. Moving on, the conclusion for this entire video. Object-oriented programming is more than just classes and objects. It is a structured way of thinking about software development. It helps us manage the complexity, protect data, reuse the code, and build scalable systems. In short, the object-oriented programming allows the user, not the user, I mean developer, write code that survives real-world challenges. Yeah, that's the video for today. Trying to stay more consistent with this YouTube video making and stuff, and I'll try my best to stay consistent with this. This is the second video I'm recording today. I hope you like the video, and yeah, please subscribe to the channel. We have 30 subscribers so far, and I'm very thankful for that. But you need to subscribe to this channel so that the channel grows and I reach more people, I educate more people. Yeah, that's your role in educating people. Yeah, that's it for today, and hope to see you for the next video. See ya.